Something that you'll discover pretty quickly is that whenever you're working with Pyro, it's a very delicate balancing act. One parameter over here is going to have a very big impact on all the other parameters. So it's a very tightly integrated system of different settings that all affect each other. Now, that being the case, my point is that whenever you introduce a new microsolver to what you're doing, or whenever you're trying to dial in the right amount for any setting, you want to try to isolate that setting as much as possible and then reintroduce everything else you already did. So in this case, I now want to introduce turbulence to this temperature field. Turbulence is going to add a bunch of noise to the overall movements of these voxels. Because right now, if I play forward, we have this right here, which is not too bad. I mean, I think this is somewhat realistic to what a coffee steam might do, but it doesn't really account for all the random motions that happen whenever hot air meets cold air. And that's what turbulence will achieve for us. Okay, so with that being said, let's now create gas turbulence. Plug that into this velocity update and bypass this dissipate that we just made. This gas turbulence works by applying a noise to the velocity field. And the velocity field is responsible for pushing our other fields around in space. So if I go to the bindings, you'll notice that this velocity field describes the field that a noise is getting applied to. So in this case, that's velocity, and that's good. But this setting up here isn't named very well. This is density field, but it really should say this is the mask field. This tells the turbulence noise where it should place the turbulence. So it's a way of masking where this effect is allowed to happen. By default, that's density. But I want to use temperature. So let's say temperature. And now, if I visualize turbulence and I go forward, you'll notice that we have these strands that represent the motion that's happening over time with this noise, and it's only happening in the areas where we have hot air, which is good. That's our temperature. We also have a control on where along the temperature you want to control this. That's this influence threshold. That basically says that if a value is ever below this threshold, that the noise is not allowed to work on that. So if, let's say, I set this to a value of 2, any temperature value that reaches below 2 will not get any of this turbulence. Or any value above 2 will get this turbulence. So now, as you can see, it's only really affecting the hot areas of our sim. Let's change this influence threshold to, let's say, 1. I think that might be a good value for us. And let's also dial in some of these other settings while we're here. Let's take this scale and set it up just so that we can really see what's going on. So 0.25. Let's take the swirl size up. I usually like having a fairly large swirl size for any turbulence that I'm doing. So let's take this to 1.5. And then to add some additional detail to these swirls, we can use a combination of this grain, which is kind of like a roughness, and this turbulence down here. I like having a high swirl size. I turn the turbulence up, usually by a couple notches like that. And then from there, I can dial in the grain to really fine-tune how this turbulence is behaving. By doing that, you can see that I'm breaking up the shape of these swirls, and that's going to add a lot more detail to how the velocity is pushing things around over time. I'm going to turn up this grain just a tad bit more, perhaps like that. And let's see what this is doing. Okay, so it's probably a little bit too much at this point. I'm going to turn that back down. And then let's now turn our scale to 0.15. So that now we can really see what's going on. Okay, cool. I think that'll work out just fine. Let's uncheck this visualize turbulence. And now, as you can see, our temperature is being thrown around in all sorts of different directions, and it's just adding a lot more of an interesting movement to the whole thing. Now that we have the turbulence the way that we like it, let's reintroduce this dissipation. We know how the turbulence should look, we know how the dissipation should look, and when we combine them, you'll notice that we are actually dissipating way too quickly now. So we need to bring down this evaporate by subtraction to put us in about the same spot as we had before. Let's say that is a value of 2. And now we've successfully combined both of those effects in a way that we want. Now, just to see this and see what it's doing, we need to turn off this temperature and check out the density. And you'll notice right away that this is creating a lot more interesting shapes, a lot more interesting behavior with how this is all reacting. The cool thing by masking temperature, or the cool thing about masking turbulence to the temperature, is that it's not really twirling things around aggressively in areas that aren't hot. It's only really taking those hot areas and throwing it around where it's hot, which is what steam would do. All right, so that being the case, let's move on to density in the next video.